Welcome back, Akira Bike Project fans. We left off the last video making good progress on the engine reduction cage that adjusts the RPM and torque for the large diameter rear tire. You may have noticed in that video though the fully assembled and nearly completed rear hub. So in this video I'm going to go over the construction and design of that hub. The hub up to this point was just made of these two pieces that I cast and machined. These two pieces sandwich around the wheel and have recesses for bearings. The two pieces just really facilitate the rolling chassis. A wheel free-rolling around the spindle, and don't have any mounts for the sprocket to actually drive the rear wheel or the brake rotor to slow the bike down. So I would need to make a few more pieces to connect the brake rotor and sprocket to the hub, and both of these pieces will need to handle a substantial amount of load with a healthy safety margin. Here is the current SolidWorks design of the rear hub. So I dusted off the old kiln and also built this larger sandbox for casting these pieces. I upgraded my foam modeling as well, making this hot knife foam cutter attachment for my CNC router, as well as this hot wire slicer for slicing thin sections. Both of these would hopefully significantly reduce machining time later. These resulted in some nice looking foam patterns that I hoped would cast well. I decided to start off with two of the simpler pieces, both essentially just ring spacers, a large one and a small one. I cut these out, glued some flues to them, and fired up the kiln. The result was that both pieces failed. The large ring did not even completely fill the pattern. The small rings, which looked like they did fill, had large voids in them. A larger disc I also cast had numerous small voids in it. Even the feeder flue in one of the small rings ended up with a large void. Casting isn't necessarily the best thing to use here, and the lost foam process is probably the least effective in general, but it's simple and easy to do at home. However, as you can see, voids and defects can end up in the part, and these in particular had numerous air pockets and voids, so these parts were all unusable. I had intended to measure out my existing parts, calculate their volume since they are relatively simple shapes, basically discs and cylinders, and then weigh them, and this would give me a good idea of if there were any significant defects in them. I also made them larger than would be necessary by a significant margin, hopefully making any sort of catastrophic failure far less likely. When I made these original parts, it was extremely expensive to have one-off CNC parts made in a professional machine shop, in the range of multiple thousands of dollars per part. However, the price of these services has dropped significantly lately, down to the hundreds per part. After discussing my project and casting failures on this excellent homefoundry.org forum, I decided it was time to get these made right. I was planning on getting them made by a professional shop just after a test run or two anyway, but thanks to my patrons and the huge price drop in these services and the good advice of fellow casters, it was just time to go ahead and do it now. I will need to get this process reliable though, as there are parts I will need to make that need to be cast. I compared the companies that I could find that provided this service, and ultimately decided to try Xometry. I first had some simple rings and spacers made as some test pieces to see how the services went. These took about 3 weeks to come in and really looked fantastic. The surface finishes were great, the tolerances were great, and the parts were really well made and deburred, reasonably priced, and didn't take too long to come in. So happy with the result, I went ahead and moved on to the larger parts, getting both the rear hub main components remade, and the third additional large component made from scratch. I also had those large spacers cut out by Syncut Syn from plate, cheaper but just as effective. In a few weeks I had all the parts in hand. I did some quick test fits of the sub-assemblies and then mocked it all up on the frame and it was looking pretty good. I have a rather unique design here with a very large diameter spindle and an unreasonably complex looking series of mounting plates. These are here to support some later upgrades, but won't be used on this particular phase of the prototype, so I'll be going into more detail on this later in the project. There were some problems though. For starters, the brake rotor mounting holes were measured by someone incorrectly to be Imperial 5/16 inch holes on a 4.5 inch diameter circle, which is of course ridiculous for a Japanese import bike. They were actually M8s on a 120mm circle. You could kind of squeeze it in, but the bolts didn't engage properly, and while this is no Mars orbiter, I think it best to get brake rotor mounting bolts to properly engage. I put this hub piece up on my rotary table on my large milling machine, dialed in the center, and drilled and tapped the 5 M8 holes. The fit looked pretty good after that. Over on the other side, the socket-headed cap screws that mounted the sprocket to the hub were also a bit too tall, and they needed to fit under this bearing mounting housing end cap. I milled the height of each one of them down a little bit to make sure the socket-headed caps fit underneath this bearing housing. A quick test fit, and everything was looking pretty good and spinning pretty nicely. Let's look at the assembly. First, we have a ring spacer / thrust bearing housing. Then we have what I've called the spindle plug, and then the spacers, the large and small ring spacers, and then the wheel mount, and then the wheel, which is not in this assembly in this video, and then the sprocket mount and sprocket, and then last, the other ring spacer bearing housing. I have that spindle plug, spacer, and wheel mount section clamped together because the wheel mount section doesn't have those 16 holes on the outer rim. So I moved that over to my milling machine and drilled those holes out. And as always, test fitting along the way to make sure everything still fits together. The next problem was that these 1/2 inch bolts that actually hold the rear wheel and 2 halves of the rear hub together have heads that are just a bit too large and interfere with the fillet curves of the hub parts. There is no room here to come in between the 2 flanges to machine that out. It could be done on a mill with a vertical rotary from the side, but I don't have one large enough. But if you could plunge through from the other side, then insert a cutter and then cut pulling backwards, this could be done. I didn't know what this tool would be called, so I went to a local machine shop tool supplier and described it, and it turns out it's a common one and usually called a back face borer. They weren't particularly cheap and had to be special ordered, but it was clear that this tool was almost the same as the shaft keyway cutter I'd already made, except the cutting would be circular instead of linear. So I went ahead and made one, and the operation was relatively easy, although a bit tedious with quite a few steps. I had to do the same cut on the other side of that hub too. The next problem was that this split rim mounts via conical lug nuts. The lug nuts pull the wheel into proper alignment due to their cone shapes. But my wheel hub is getting sandwiched between 2 larger hub halves, so the lug nuts are not outwardly exposed. I considered a few various options and decided I could mill down the lug nuts a little bit and then clamp the other half of the hub over those with a recess drilled into them. The lug nuts would center on the rim, and then the outer bolts torqued down would hold the hub in place and provide the extra downforce on the lug nuts. Satisfied that that solution had a high chance of working, I went ahead and milled the lug nuts down and then tested the fit out on a little test piece that had the same depth recess machined into it. And time for a quick test fit. Definitely not going to be able to torque it as much as it ought to be torqued, or I might not be able to, but this whole hub is getting sandwiched between 2 massive aluminum plates with a heck of a lot of torque. If I get the cut depth exactly right, these bolts will have a ton of torque on them. Anyway, this is the test piece, but that's exactly what I'm looking for. think that's looking pretty good. And a regular bolt will go above that. I milled out the recesses in the hub plate with a large annular cutter. And let's put it all together and see how it comes out. Alright, so I finally got the assembly together with the correct 1/2-inch bolts, 1/2-inch 20 with the lug nuts, the cut-off lug nuts under that. I did need to open these holes up just the tiniest bit to 33/64, and I happen to have a reamer to do that. And I was finally able to drop it right on there, so looks pretty good. That hub piece you were seeing there was one of the ones I cast and machined, so I did have that professionally remade also through Xometry, after updating the design with the changes I had to make here. I think you can guess which is which here. Because these were made with the right tolerances, I had to press the bearings in. I heated the hub parts in a toaster oven, and froze the bearings in my freezer, and then quickly pressed them in place on my pneumatic press. It was quite tense doing this since I had to rush it before any temperatures changed too much, and if I screwed it up, the whole piece could be ruined. I also went ahead and had the spindle mount blocks remade professionally, as well as the flat steel plates that attach those to the frame. Mainly because I needed the 4 holes in those to be threaded, since there wasn't enough room for a nut on the other side. And also the old ones just looked terrible. And now I could go ahead and assemble it all on the frame. I removed those new spindle mount blocks and the spindle frame post jig, which held everything in place for welding those new steel plates in, and tried to install the rear hub on the frame. I'm hoping I could get it in here without having to remove this right side. Let's go ahead and give it a shot. Not a chance. No. No way. So either I have to assemble it in place or take that right half off. Assembling it in place also did not work because of the tight fit between the spindle mount blocks and the thrust bearings. So I went ahead and removed the right side of the hardtail rear mount. And started putting the pieces together. I got a little help from a bungee cord. Since I was putting a lot of cantilevered weight on the spindle here, I was worried about my tack welds breaking. The assembly went well though, so now I could go ahead and put the right side back on. It was a tight fit and needed a little bit of help, but ultimately it went together fine. The right side spindle mount block was added and we were good to go. Alright, I got the end caps in, the center bolt, and we're pretty good. Look at that. And there you have it, the rear hub complete and assembled. There were some other minor challenges, but this video was already getting pretty long, and you get the idea. That is it for this video. Thanks for watching. I hope you're enjoying this journey where I am building a fully functional high-performance recumbent motorcycle inspired by Kaneda's ride in Akira, but aiming to take full advantage of the platform and being set up for manufacturing with frame jigs, fixtures, and molds built along the way. Please subscribe, and if you like the project, become a patron. I'd like to welcome my newest patrons, Noah J and Mechubus. Thank you both. I really appreciate the support for this project, and every bit helps accelerate it. Thanks again all, and see you soon.